I'm really happy to welcome you to this next session. We're going to shift gears a little bit. So this morning we heard about the power and opportunity to bring intellectual diversity, institutional diversity, cultural diversity into our work. And of course what that means is forming teams that have to grapple with that diversity. And so what this next session's about is the principles, the evidence, and the practice of team science, otherwise known as the science of team science, and some ideas on how to really make that work for you. Before I introduce Kara, I want to tell a brief story about myself that involves risk-taking by a PI and by NSF. The risk taker is Margaret Palmer, the PI on our center, who took a risk on me. I'm an economist. She's an ecologist. And she actually recruited me to help form pre-proposal this center that we are now happy to have been engaged in with for 8 years or so. And then that risk-taking was rewarded by NSF. She took what was traditionally an area of biology and ecology and really expanded the disciplines that were brought into that, and NSF loved that. So that's the moral. Okay, with that, I'm really happy to introduce Kara Hall. Kara is the director of the Science of Team Science team and director of the Theories Initiative in the Health Behaviors Research Branch at the National Cancer Institute. She has a PhD in psychology from the University of Rhode Island and has really wide expertise, including in health science, team science within the health sciences, research on health behaviors, and she's also developed practical tools to help organizations with the challenge and opportunity of making team science work. So we're really happy and lucky to have her here today. Please welcome Kara.
So I'm very happy to be here. I'm excited to have a chance to talk with you all. I'm going to talk a little bit about the science of team science, highlight some findings, some evidence from some of the work that I've done and others in the field. And then I'll spend throughout that kind of highlight a little bit about some strategies and some lessons learned. And I look forward to discussion as we move forward. And just to give a little orientation to how I got to the National Cancer Institute as a psychologist, I was recruited by a gentleman named Dan Stokels, and he was there at NCI to try to understand how and whether the value of bringing large centers together, specifically around transdisciplinary science, was the way to go for NCI. And this was back in the late 90s that the initiatives had just started, and or that they had started, and in 2005 is when I got there to NCI. And so what they were trying to do is deal with the challenge of the silos and in those silos having the kind of breakthroughs that were needed in cancer prevention, and tobacco research in particular was where they started doing some of these experiments. And so they said, we want to be moving to a more integrative model. We want all of these different disciplines to be working together to try to achieve some of the health outcomes that we need. And so when I got there, there was very little work that had been done in the context of science teams and thinking about particularly around transdisciplinary science. And so we started to build some models for trying to think about how to approach this problem and look at how these scientists were working together and how those collaborations would lead to the kind of outcomes that we wanted. And so, in essence, I used these four Transdisciplinary research centers as our laboratory for trying to understand how this work was being done. And we did a whole variety of studies looking at integration, collaboration, productivity, research orientation, training, and used a whole range of methods from quantitative to qualitative, science mapping, social network analysis, and so forth. So, as we started to try to understand what was happening, we did these range of problems, and we started to realize, wow, there is so much here that we want and need to know. And that led us to think about bringing a community of people together to try to really understand this problem. And so we launched an effort to develop this field called the science of team science, where we were hoping to understand not only the value of team science, but understand the processes that were needed to successfully do that, the characteristics and skills that were needed for our scientists to engage, and the kinds of policies, for instance, tenure and promotion policies, that were needed to really support this kind of work. And so, in 2006, we had this conference where we coined the phrase, the science of team science, and that led to a special journal supplement in the American Journal of Preventive Medicine, and a whole range of activities that have taken place. I had the honor of being on a National Academies committee around a committee on the science of team science, where we released this report in 2015, and it's been in the top 30 most downloaded reports since they've started publishing reports in electronic form. It's in 1994, so it's been really well received, and that's been very exciting. And so we've had a yearly conference, and just recently launched a society even. So in addition to building the evidence and building the community, we've also been working to develop tools and resources to help scientists do the work that they're trying to do in teams and working across disciplines. And so my colleagues here have been contributing to these variety of articles. We have the Team Science Toolkit, which is a web-based repository where you can find articles, practical tools, and examples of things like hiring letters when you're trying to go on to an interdisciplinary track, or if you're trying to start to collaborate with colleagues, you might look at the prenuptial collaborative agreement that our former NIH ombudsman had developed. And so there's lots of resources that are beginning to emerge. And although we were looking at, I started looking at these transdisciplinary research centers, the kinds of work that's happening in science can range from 2 people working together to 2,000 people working together. If we're talking about the CERN Hadron Collider, there we're talking about teams of teams, multi-team systems. People can be globally distributed, working across industry, academia, government. They can be engaging citizens and working across a translational spectrum. And so those variety of teams, along with these other dimensions, for instance, having either a unidisciplinary focus or a transdisciplinary focus, being co-located or globally distributed, all of these different facets of teams and team science create this idea that there are a variety of different profiles. And because of that, we don't have a one-size-fits-all kind of solution. So what's going to work to try to increase the effectiveness of a team of 2 people at the same, in the same department at the same university is going to be different than what's needed as we increase the complexity of our scientific collaborations. And so with that, we can think about how collaboration is complex. It's multi-level, multifactorial. When we think about intrapersonal factors, what is the willingness of someone to actually engage with others, share ideas with others? How is their ability to communicate their ideas? Are they able to effectively talk about their science in a way that someone from another discipline can actually really understand? What are the organizational factors that help to bolster and support the kind of work being done in teams and so forth? So I was asked to talk a little bit about, what is team science? How is it different than other teams? When we're talking about team science, it's really an approach to conducting research, and that's done in a very complex system. So we have our scientific enterprise, which is complex, and that's embedded in our society. And it requires at least 2 people to be engaging in that work, is typically interdependent. And so people are relying on each other in a variety of ways in order for their work to get done. And what makes science teams different than other teams in many ways is the context in which they're embedded. And so the context of academia is quite unique. The legacy structures that we have of disciplines, the types of support that we get, the ways in which researchers are funded, whether and even within our academia, the way in which some are funded with hard money, with soft money, with university funds, with funds from industry, and so forth. So the range of different ways in which we're supported. The rewards and incentive structure, that's quite unique. This tenure and promotion system that we have that really drives the way in which we do our work. We are, as humans, we tend to do what we're rewarded for. And so we are rewarded to do publications, and so we do lots of publications, and those kinds of ways in which we structure our rewards and recognition really drive the way in which we conduct our business. And so as we think about the way in which our reward structure is geared towards individual scientists and individual scientists focused in their disciplinary departments, we start to see how those systems aren't quite aligned with where we're going. And so I'll talk a little bit about how things are need to change and hopefully will change. The types of metrics that we're looking at, and other issues like the motivations for collaboration, or the fact that sometimes our collaborators are also our competitors. And so sometimes we're working with a collaborator on a grant, and sometimes we're competing against them, and that also creates some unique factors. So speaking of metrics, I'm now going to share just some highlights of some findings around team science and the effectiveness and productivity and so forth. And so many of the studies that are in existence today in this rather nascent field has a very heavy emphasis on our primary outcome, those publications and the different metrics that relate to that. And so we have, when we look across the collaborations that are crossing boundaries, whether they're crossing countries, universities, or departments, what we're finding generally is that those boundary crossing collaborations are leading to higher impact publications than work being done by co-located teams or solo teams. When we look at crossing boundaries with respects to disciplines, we're finding that cross-disciplinary teams tend to be more productive than comparison teams, producing more innovative products, having a greater scientific impact, having broader reach with where the publications and the dissemination of the science is going, and so forth. And so this is a positive thing with respects to the discussions we're having here today. This is aligned with sort of what we might hope. And this is a study that myself and colleagues did looking at one of those research centers that I mentioned in the beginning. And here what we did was we tried to compare the transdisciplinary center initiatives with matched R01 grants, and at NIH, that's sort of our key grant, the kind of grant that you would get in order to move forward on your tenure and promotion track. And so we compared the R01s with the transdisciplinary research centers. And what we found was that there was a lag period in our transdisciplinary centers with respects to productivity. But at around year 4, we see that the productivity of the number of publications that the centers were producing really took an upswing and then really outpaced the R01, our sort of regular grants. And so this was an interesting and exciting finding, right? We find that, okay, when we're working in this kind of framework, this structure, that we're getting, ultimately getting the kind of publication gains that we might want to see. Well, we also see that there's that lag period in trying to understand what that's about. And so we've continued to do some research around that, and some of the things that we've uncovered, which probably is no surprise to this group, is that some of the startup activities, the getting to know one another, trying to understand the language of someone who's, when you're working with someone from another discipline, the negotiations of indirect costs, and all of these things really kind of create a startup challenge. Particularly, these are centers that were launched at a time when many of these issues weren't highly recognized and thought about in a really deliberate way, and so they were working their way through these challenges. What's interesting is that when we look at another study by Cummings and Kiesler, who looked at about 500 NSF projects, and when they did an analysis that looked at as the number of investigators increased and the number of disciplines, or as the number of investigators increased and the number of institutions increased, what they saw was a degradation of effect with respects to productivity for the teams. And so as you increase the number of disciplines, they were finding slightly lower number of publications, and same with the institutions. But what's interesting about this is the work that they did beyond this, because you might think right at the outset that that's counter to some of the other findings that we saw. But what's interesting is that when they looked at some of the mediating factors, particularly coordination mechanisms, what they found was that was related to the likelihood of the success and the positive outcomes with respect to productivity. And so what they saw was that the more coordination mechanisms that these projects used, the better their outcomes. But the counterintuitive finding was that the greater number of the universities that were involved in these projects, the fewer the coordination mechanisms that they were actually using. And so what was happening was that the dispersed projects were using fewer mechanisms, and therefore were having poorer outcomes. So this idea of coordination and the challenge of these mechanisms when you're using, when you have more people involved and more disciplines involved, is that it requires us to be thoughtful about the way in which we're engaged, the coordination, and the way in which we structure our work. And so one of the things that I really want to highlight is that we will be talking, we've talked about earlier today and throughout the day and again tomorrow, different team principles, different organizational theories that we can be bringing in, and all of these things are important components for us to be thinking about the way in which we can use that knowledge to structure the way in which we do our work. So what I want to be saying as I'm trying to illuminate some of these things is to be thinking about the fact that when we think about coordination, when we think about, say, project managers for a research project or a research center, that it's not just having the people who can come in and do any kind of coordination. It's being strategic about the coordination that needs to happen. And I'll point to that as I go forward. So some findings around gender, culture, and ethnic diversity. There's some studies that show, for instance, that gender heterogeneous authorship teams have 34% more citations. If you have a grant proposal with at least one female PI, there was a greater likelihood that the proposal would get awarded, and that it would produce innovative ideas. With respect to cultural and ethnic diversity, looking across the studies, an interesting finding here was that that basically a moderate level of diversity appeared to be better than no diversity, and also better than very high levels of diversity. And this is an example of a finding that I think is, in this nascent field, has not been sort of worked through all the way, but has really important implications for us to be thinking about. So does this mean we shouldn't have very diverse teams? Well, I would argue, no, you should have the level of diversity that you need on your team to really contribute to the scientific question that you have, to bring in the voices that you need to really answer the question. What's important here is to think about why high levels of diversity would be a problem. So there's some research that talks about this phenomenon of fault lines. And a fault line would be, for instance, if you had 2 male doctors and 2 female nurses. Well, a fault line is around grouping, a sort of grouping variable, where people feel a sort of kinship in some way or another that binds them together in a way that they might sort of have common interests. And so if you have 2 male MDs, well, there you have gender separating the male doctors and the female nurses, but you also have the status and different roles of their profession. And so these kinds of fault lines, these kinds of ways in which we can have groupings occur in our projects and our groups and our teams can influence the way in which knowledge is shared, the way in which people are collaborating, the way in which conflict might play out. So when we're thinking about the way in which diversity and the way in which we're going to construct our teams is thinking about what are the things that we really need in order to answer the questions that we're trying to answer, solve the problems that we're trying to solve, and then thinking about what are the ways in which those teams might introduce certain kinds of problems. So when we think about team size, much of the science of teams literature talks about an ideal team size of, say, 6 to 9. We're not necessarily seeing that same outcome in the research around science teams. And we could talk about that in a variety of ways. But one of the things that's interesting is, again, to think about the fact that the size of the team should not necessarily be dictated, should not necessarily dictate the way in which you construct a team. You should construct a team to really be able to solve the problem you have. But when we're thinking about managing the way in which groups are working together, the way in which we're going to manage our workflow, then we might think about if we have a group of 20 people that we need to be weighing in and contributing to a project, how are the ways in which we can leverage smaller groups in order to maximize the team dynamics, but make sure that we have systems in place to allow the knowledge exchange and flow across those subgroups. So that's an example of thinking about the way in which we can structure and set up processes to deal with some of these issues. Some other interesting findings are that when we look at people who have a history of collaboration, so if you have a team that's continuing to work together over a long period of time, that often will enhance the productivity of that group, but might decrease the kinds of breakthrough products that they develop together as a team. And part of that is, as you're working together with the same people, you're really having the opportunity to be a well-oiled group. You've worked out perhaps the way in which you deal with conflict and the way in which you manage your workflow, but you might not be having the benefit of new ideas coming in to the group. And so what they find with respects to innovation is that having newcomers added to a group is really an important component to driving new ideas. So thinking about some of the research on different roles, different types of people who are contributing to a team, I highlight this one comparison here, which is there's some studies that show that postdocs with external funding, so sort of their independent, they have their independent funding and they're contributing to some publications. Those publications tend to be more breakthrough publications. When you have postdocs who are contributing to a paper, and those postdocs have been hired onto a project, and their primary role is to contribute to a particular project of someone else's idea, so as a contributor, not a leader. That is increasing the amount of productivity of the team. So we can think about what's happening here in a variety of different ways. One which is that we can imagine that we're seeing these differences between, well, maybe the postdoc has their own funding because they are a star researcher, right? They have the motivation to go out and get their own funding. But we could also think about the fact that when we hire postdocs onto a particular project, that's increasing the likelihood that they are doing the kinds of work that's really moving things forward. They might be picking up tasks that might otherwise be done by, say, a project manager. If there isn't funding for that project manager, they're doing a whole array of work within the context of the project, but not necessarily having the time to sort of push new ideas forward. So this, again, a sort of theme here is thinking about, the way in which you're constructing the team and the way in which you're resourcing your team is going to impact the kinds of outcomes that you'll be getting. So now just reflecting on an interview study that we did with one of our transdisciplinary center initiatives. Our centers often look something like this. We have multiple research centers, a coordination center, and we have many, many disciplines that are contributing to the science there. And what we did was we took some time to talk to the investigators at the end of 5 years of being in one of these transdisciplinary initiatives and asked them what they felt like the challenges were in engaging in this kind of science. And for these researchers around conceptual and scientific challenges, they felt like it was really stretching their intellectual capacity more than the work that they were used to doing. This need to be working together with people from other disciplines, trying to do this integration work was really challenging and more complex than they were used to. Again, these ideas of having to understand different disciplinary cultures. Oftentimes we saw that the researchers were engaged in these transdisciplinary researchers, but had this tendency to want to pull back and sort of go back to their own comfort zone, saying, well, can't I just do my work and give you the findings later, rather than sort of staying engaged in that integrative approach and the need to continue to have this dialogue amongst the team. It obviously can introduce more management and planning issues and a variety of compromises, and of course, the issue I brought up before around the tenure and promotion. With respect to the impact that they felt like it had, what was interesting was it started to change the way in which these scientists were doing work. So the more opportunity they had to do this highly integrative work, the more they became compelled by the kinds of science that they were doing, the more that they learned to appreciate that the value that the others brought to their research and to their thinking. And that led to new boundary-crossing collaborations for these researchers, which led to important scientific progress. What was also interesting is getting a pulse on sort of the way in which these things are changing the culture of our science and academia, is that once they started to gain these important scientific findings and progress, that became compelling to their institution, and the institution started to make some changes to support the work that they were doing. And that also led to some career development and advancement. And this has been an issue that's talked about a lot, the challenges for our careers of junior faculty moving into interdisciplinary paradigms. And what's interesting is that the center mechanisms allow some flexibility to thinking about how the science is structured and supported. And so we can think about the use of seed money or pilot funds that are within a center structure. We had two different center initiatives use their pilot funds in different ways. One center initiative used their pilot funds to specifically support junior investigators to do cross-center collaborations, and those cross-center collaborations also had to be cross-disciplinary. Another initiative decided to use their pilot funds to support the PIs, kind of pooling their money and pooling their resources to do another project. What was interesting is that the ones who used their pilot funds for the junior investigators, they developed a whole cadre of new leaders in science in new niche areas of science, because they were doing these interdisciplinary and transdisciplinary projects, and really created a whole array of new important directions for science. The other initiative used their pilot funds, and they got some really exciting findings, but in a very different way. They continue to support the PIs, and they got an important finding. But you could see how one choice in how to structure the way in which they're distributing funds and supporting the different types of research can really change the trajectory of what comes out of one of these initiatives. So when we looked across these initiatives, we found that there's greater integration, collaboration, productivity, and reach, and that it really started to help us understand that there was an added value to doing this kind of research and providing the right structures for it. And we're continuing to think about how to build on the lessons learned and with a variety of conceptual models. And I see that I have about 3 minutes and I have about 10 more slides. So what I would like to do is share with you that myself and colleagues developed this model of four-phase model of transdisciplinary research, and I will foreshadow it for you, and you can take a look at it. What I did was try to think about the different phases of research and the key processes that might be most salient during those phases, in part because the science of teams literature was quite overwhelming, and there's so many things that one could think about in trying to enhance the way in which they're doing science. And so this provides an example such as using externalized group cognition, making sure you're using a lot of visual, it's a fancy word for just putting things on paper, using visual aids to help facilitate a process of discussion and understanding and shared vision and mental models. In the conceptualization phase, this is I would say that the development phase, that's a little bit more of maybe what you're doing here in a planning grant phase. The conceptualization phase, when you're thinking about writing the research proposal, you're needing to work together to generate a shared language and understand who does what. compilational transactive memory is just understanding who does what. As you move forward into the initiative, you not only want to know who does what, but who knows what, who does what, who knows what, how things get done, and so forth. In the implementation phase, in the translation phase, you're sort of recycling through. This might be that you have some findings and now you want to bring it out to the community, and so you need to be thinking about who now needs to be brought in and how that might change your goals and so forth. And so my last couple slides, I thought I would go sort of macro to micro. I heard mentioned earlier this idea of culture shift, and I thought I would share some snippets from some research that we're doing looking at tenure and promotion policies. And I was thinking about the idea that we have disciplinary oriented independent scientists, thinking about how to reward people for their independence. And when we look at the tenure and promotion policies that are really cutting edge, they are really struggling with this tension of the fact that the work that's done by transdisciplinary team scientists is interdependent. And so they're trying to use a system that's designed for independence and put it into a team context. And so even though they're making these efforts, there's still this real tension. So for instance, it says, okay, we're gonna encourage people to pursue innovation, even stuff that's happening in between the edges, right? So this is a university that's trying to say, yeah, we're gonna support interdisciplinary research, but sort of the language that they're using is a little bit qualified. Another says, well, okay, we can think about evaluating our people working in teams, and we're going to have letters from collaborators that are attesting to their autonomous contribution. So that's a really strong way of articulating that. And maybe they can do this kind of work. Perhaps we'll let them include some publications that are collaborative. So there's a lot of work that we need to do. There are policies that are doing a little bit better job than that, but there's still none that are really thinking about how to make a paradigm shift to rewarding teams in a real robust way. An important component of what you're trying to do here with the ERCs is thinking about workforce preparation, and so just highlighting that there's a lot of skills, there's a lot of competencies that are going to be needed for people to be able to do this work successfully, and thinking about how we can be pushing that forward. And then this is an example of a tool that we've developed to try to help structure some of this vast and somewhat daunting and overwhelming amount of things to think about. And this is a framework that's available on the toolkit. I'll show you on the next slide where you can find it. And this is just a way to think about if you're planning, as you're planning for collaboration, what are the different elements that you might want to think about as you're developing a plan. And so here is my information, the way in which you can access the Team Science Toolkit, which all of the tools and resources that I highlighted and talked about are available through the Team Science Toolkit. We also have our Science of Team Science conference in May, and that usually has about 50% of scientists who are studying teams and 50% who are practitioners who are coming to talk about and learn about how to do their work more effectively and efficiently. And so thank you very much.